Algebra friends. Welcome to day 14, where we're going to look at writing some equations for situations, and they're technically linear. And then we're going to work on getting information out of the equation, using the equations to help us find answers to these questions. I'm still up in Houghton Lake, my mom's house where I grew up. You can tell by the sick wood paneling and the sweet decorations. Okay, and I hope you've all been able to keep going, working hard with the good weather, but enjoying the good weather, and just I want us all to just really focus on finishing strong, doing everything we can. Remember to email me if you finish something up. Email me if you have questions. Take advantage of those office hours. I'll have office hours again Wednesday, 3:30. It's going to be our last opportunity, so it'd be great just to see you, say hey, and so I can wish you off to awesome things I get to see you do at the high school the next 4 years, and I look forward to when we can high five and junk again. I've been missing y'all, so let's get after it. So we're looking at linear word problems. So I'm not a big fan of the words word problems, but maybe contextual situations might be a better way to put it. But let's take a look. So first we have Jake and Steven and their wrestlers, and I don't know if you know this, but wrestlers need to make weight. So Jake is 160 pounds and he's gaining 2 pounds a week. Steve is 185 pounds and he plans to lose 3 pounds a week. So this equation, it's asking for when are they going to be the same weight. So I'm going to use W for weight, and I am going to just take this situation in words and put it in a situation as an equation. So Jake is 160 pounds and he is gaining 2 pounds a week. So 2W. And you can kind of think of those 2 pounds per week as, it's kind of like a slope. Every week, too. He's starting at 160, then add on 2 a week. And we want to know when they are the same. So I'm going to set this equal to Steven. And Steven is 185 pounds and plans to lose 3 pounds a week. So all I did here is I took the situation and made it an equation. I've got Jake, who's 160, and then 2 pounds a week. When is that equal to Steven, who's 185 and losing 3 pounds a week? That's all I did. That's it. So that's number one. There's an equation for us. Number two, how long will it take to reach the same weight? So what that means is W is weight, or weeks, the time. So W equals question is kind of what number two is. How many weeks is it? So I'm going to use algebra, or isolating a variable, to do this. So here's my answer for 1. But from there, I'm going to get my variable on the same side. I'm going to solve for W. So 160 plus 5W is 185. I'm going to take away 160 from both sides. 5W is 25. Divide both sides by 5. And that tells us after 5 weeks, they'll weigh the same. And that makes sense. This guy's starting lower and going up. This guy's starting higher, going down. Eventually, they're going to meet, and they meet at 5 weeks. So that's question 2. Question 3, at what weight will they be? Well, it doesn't matter who I test, right? They're going to be the same. So I'm going to choose to test out right here. Let me highlight that. 160 pounds plus 2 pounds a week for 5 weeks, because I already know 5 weeks is when they are the same. So 160 plus 10, they'll be 170 pounds when they're the same and they get to wrestle each other. Sounds like a good time, all right? Next, we're going to talk about let me give you a reminder. There's a lot going on there. Rewatch it if you need to. Rewind. You have all the power in the world at your device right now. Rewatch it, rewind. Try it out on your own. You can hit pause, try to write it out, see if it matched up what I was doing, and so on. Let's check out this mountain climber. This guy's up on the mountain, dude, and he got hurt. Maybe it was slope, dude. He was up on the slopes, bro, and he's just trying to get it done and got hurt, okay? His buddy called for help, and then the two begin to descend. That means go down. So they're at 15,000 feet up in the air. That's way up, okay? And they are from the 50,000. And so they're going down at 250 per hour, okay? Then the rescue team, they're up in the mountains, but they're only at 8,000 feet, and then they need to go up. So I'm going to start circling all the stuff I need, okay? So write an equation to show the rescuers meet the climb after 8 hours. So when are they going to be equal again, okay? So the first crew, those guys stuck up there, They're at 15,000 feet, and they're coming down the mountain at 250 feet per hour. You know, they're probably a little slow because the one guy's hurt, man. The rescue team, they're starting at 8,000, and then they're going up 1,000 feet each hour. So I can read this back without even looking at the words. The one crew, they're starting at 15,000, they're descending 250 feet an hour. When is that going to be equal to the crew that's at 8,000 feet and going up 1,000 an hour? When is it going to be the same, right? They got to catch Slope Dude up there before he falls off the cliff. All right, he's hurt. So that is number one. Here's an equation, and this equation just says what the situation says. Problem 2, how long does it take? So for number 2, I'm trying to figure out how many hours, okay? That's what H is, how many hours. So this is the answer number 1. Number 2, I'm going to start isolating the variables. So I'm going to add 250 feet per hour each side. 15,000, I got 8,000 plus 1,250 H. I'm going to subtract 8,000 from both sides. Now I might need my calculator, we'll see. So that gives me 7,000 equals 1,250 H divided by 1,250 divided by 1,250. So H, I am going to need my calculator. 1, 2 is 25. It's not going to work super pretty. So I've got in my calculator, oh man, my phone just gave me a million notifications. What's going on? Okay, 7,000 divided by 1,250, and that gives me 5.6 hours. Okay. Or you could say, if you really, let's stay with the decimal, but you could say 5 hours and 36 minutes. Those would be the same thing. Okay, so that's number 2. How long? Number 3 says, how high will they be? Well, it doesn't matter which one you use, right? Because they're the same height at that hours. So I'm going to put that 5.6 into this right here. Okay, so 8,000 feet plus the 1,000 times the 5.6 hours. That's going to tell us how high they were. So calculator action. 8,000 times 1,000 times 5.6. Oh, I did something wrong. 8,000 plus 1,000 times 5.6. 13,600. And that's, and remember, I'm going to be using a lot of units, commas. When you do it in the Go formative, make sure you're using units and commas and stuff to make sure that it marks you as right, okay? Yeah, so also take a step back and, you know, always ask yourself, does it make sense? So the group that's going down from 15,000, is this lower? Yeah. The group that's going up from 8,000, is this higher? Yeah. And it should be closer to the top group because the group that's coming up is going 1,000 each hour. So, you know, always restate your question, say, does it make sense? And, you know, hit me with those questions. Make sure you're working your hardest, and I got your back, all right? Miss you all.